I mean, the first section's super easy, but I never actually included it in any of the videos. So let me just do one example. Maybe these are all ridiculously easy. Maybe just do this one right here, yeah? Okay, so let's cancel things out. When you look at 12 over 9, just think of the fraction 12 over 9. 12 over 9, you could reduce it, right? What could you reduce it by? By 3. So if you were to divide both top and bottom by 3, divide both top and bottom by 3, you're going to have a 4 left over. 12 divided by 3 is 4. And 9 divided by 3 is 3. Don't forget about that negative sign, so you can put that in front of the 3. Now how about m's? Well, you have one m on the bottom that completely cancels out with one of the 8 up on top, and you're going to have 7 m's left over up on top. And then you have 4 y's on the bottom that completely cancel with 4 of the 6, which means you have 2 left over up on top. So your final answer here is 4 m to the 7th y to the 2nd over negative 3. That's probably as hard as this first section gets. I mean, down here, this is ridiculous, right? You're just combining like terms. Well, I guess technically you need to distribute that minus sign first, and then you'll have 6w minus 11w squared minus 4 minus 7w squared. So it's just combining like terms. Go with the highest exponent first. You have a negative 11w and a negative 17w. That's going to be a negative 18w. I forgot to say squared. Negative 18w squared. And then you just put it in order. The next term would be a positive 6w and minus 4 at the very end. Easy stuff, right? Easy peasy. Just real quick, again, even though this is already on the other video, right here you are able to split the denominator to each one of them, to write each one of them over 5r to the 4th, and then just cancel things out. Okay? So, same thing here. You could split each one of them. The only reason why you're able to split them is because you have a monomial in the denominator. Okay? So over here, you don't want to split. Right here, you might as well divide it the quickest way you can with synthetic division. So synthetic division works right here. You simply put the negative 2 in the box, and then you put your coefficients 1, 7, and 10, and you guys know how to do the rest, right? So synthetic division is awesome. You could do it on that one. You could do synthetic division on this one. You could do synthetic division on this one. Oh wait, we're skipping this one. But you could do synthetic division. This one right here, you could do synthetic division. This one right here, don't do synthetic division. Alright? This one right here, you have to use long division. Why? Because it's not a nice x plus 2 or x minus 1. It's a 2x minus 3. That messes everything up. So we're not going to go with synthetic. Right there you have to set it up with long division with the 4x squared inside minus 2x plus 6 and the 2x minus 3 on the outside. Okay? So that's already explained on the other video. Sorry about that. I don't want to take up your time. Look for it on the other video if you need help. Let's jump to analyzing graphs. So right here, we could name off a bunch of things about number 8 right here. I just randomly picked number 8. Is it an odd degree function or an even degree function? Even. Of course, there's 2 arrows going up. So that's an even amount of arrows going up, so that the degree is even. Okay? If you would only have 1 up here and 1 down here, like if it were to go back down this way, instead of going up, if it were to go back down, then it would be an odd degree function because you have 1 up here and 1 down there. But because both of them are up there, 2 of them up here are even, right? Even degree function. The a value, is it positive or is it negative? It's positive because it's opening up. Okay. What else could we ask? We could ask, how many real roots does it have? How many real roots? It has 1 right here and 1 right there, because real roots are real answers, which are real x-intercepts, right? So if I say how many, you're just going to say 2 of them, because there's 1 here and 1 here. If I say give a decimal approximation of those roots, then you would say, oh, this root right here is actually -2, -3, -4, -4.2. So the answer is -4.2 if you wanted to give a real root for that one right there. How about for this guy over here? What would you say it is? An approximation. x is approximately what? 3.2 or something like that. Does that make sense? Okay, so now let's talk about absolute maximum, absolute minimum, relative, which means local max and local min. Okay, so we need to know the difference between absolute maximum and relative maximum. Okay, so we all know what a maximum value looks like. Look, you're going down on this graph, and then all of a sudden you curve and you go up. Then it reaches a high point, and then it goes down, and then it reaches a low point, and it goes up. So if I say, what's the maximum value, you're probably going to think, well, this is a max value right here. Now, the thing is, that's a relative max. It's a local max. In other words, if you focus in on this part, yeah, from here to here, it's going up, going up. It reaches the highest point, and then it goes back down. But if you look at the whole thing, it turns, and it goes back up, and it goes higher than this point. It keeps going up forever. So when we say absolute max, what is the absolute max? Positive infinity. Because when you're thinking about the highest point on this graph, it goes up forever. It goes up forever this way. So there is, the absolute max value is positive infinity. But when I say relative max, okay, well, that would be talking about this guy right here. Okay, so what would that coordinate be for the relative max? If you're going from the origin, it's -1, let's say -1.5, and then -1 and -1.5. So -1.5 and -1.5. That's an approximation of the relative max. Does that make sense? Okay, now let's talk about absolute minimum and relative minimum. Is there a minimum value? Absolutely. This one's a minimum right here, and this one's a minimum right there. The question is, which one is the relative and which one's the absolute? Which one's the absolute? The one on the left or the right? The one on the right. When I say absolute minimum, I'm talking about the lowest point on the graph. So if you say that this guy right here is the absolute minimum, that's incorrect, because over here it goes down all the way to -4. And notice that this one, it doesn't even reach -4. So this is a relative minimum. This is an absolute minimum. So if I say for the relative minimum, you would give the coordinate that's about right here, right? This coordinate about right there. So what is that coordinate? That's about -1, -2, -3, -1, -2, -3.5. So you could say about -3, -3.5. That's a relative minimum. But the absolute minimum would be this guy over here, and that coordinate is roughly 1.5, and then 1, 2, 3, 4. Okay, so that'd be 1.5 and -4. That's the absolute minimum value. Do we understand the difference between relative and absolute? Yay? Okay, good. And for the final touch, do we know what the domain and range is of this entire graph? The domain is talking about always your x values. So x is what? Let's think about this. Does this graph right here, does it go to the left forever and to the right forever? The answer is yes. Even though it curves up, it never goes straight up. It always drifts to the right. It always drifts to the left. So the domain is x equals all real numbers, because the graph is it's to the left and it's to the right forever. Now when you talk about range, you're talking about the y values, and the range, it's either your graph is above a certain value or below a certain value, or it goes in both directions forever. Does this graph go up and down forever? No, it just goes up. And obviously we stated that this was a minimum point. So the lowest point is right here, and we're talking about y values only. What's that lowest point right there?
-4.
-4. So y, all of your y's of this graph have to be up here above that -4. So what inequality describes that above the y value of -4? What inequality it says y is greater than or equal to -4. That's your range. Make sense? Now, let's just keep talking about range right here. The range right here would be y is what? Greater than or equal to what? 0. Easy, right? How about over here? The range is what? Y is it greater than? Is it less than? Is it above a certain value? Is it below a certain value? Or is it both above and below forever? Both above and below forever. So the range is actually all real numbers in that case right there. Because the graph really does go up forever and it really does go down forever. So on number 5, there's an absolute maximum value of positive infinity. There's an absolute minimum value of negative infinity, but there is no relative max, there is no relative min, because this is a perfectly straight line. It never reaches a certain high point and then it goes back down. It's a straight line, so there is no relative min or there is no relative max. But there definitely is an absolute max, which is positive infinity, and an absolute min, which is a negative infinity. Number 2 on the third page, 5.7. This one's interesting because it looks like a quadratic trinomial, and you could actually treat it like a quadratic trinomial, like if you were going to factor it and set it each equal to 0. The only difference is it's not x times x, because x times x is x squared. It's actually x squared times x squared. So you could still think what times what is 4, that if you add together is -5. Well, that would be a -4 times a -1, and if you combine those it gives you -5. So now because there's zero product property, you could take these guys and split them and solve. So you could actually say x squared minus 4 equals 0, and x squared minus 1 equals 0. And now you could actually solve it by adding 4 to both sides. So you'd have x squared equals 4, and you'd have x squared equals 1 if you added 1 to both sides. And then you would apply a square root to both sides, and your answer would be x equals plus or minus the square root of 4, which is 2. And the other one, you would also apply a square root on both sides, and you get x equals plus or minus the square root of 1 is 1. So you get those 4 answers, x equals plus or minus 2 and x equals plus or minus 1. Get it? Number 4, factoring by grouping. So is the way to do it. I want to take the first 2 terms and I want to pull out an x squared. If I do pull out an x squared, there's going to be an x plus 1 left over. Maybe I should do that in blue. X plus 1 left over. On the other group, if I pull out a -3, I'm also going to have an x plus 1 left over. So we're going to factor by grouping. We're going to pull out the common x plus 1. And what would be left is the x squared right here without the x plus 1. You just bring that down. And we also have left a -3. Just bring that down. So you really have x plus 1 times x squared minus 3 equals 0. Let me bring down the equals 0. And let me split them using the zero product property. X plus 1 equals 0. X squared minus 3 equals 0. So you're really going to get x equals -1. That's an answer. And over here you get x squared. If you add 3 to both sides, it's going to be x squared equals +3, which means that you need to apply a square root, and you'll have x equals plus or minus the square root of 3. So you actually have 3 answers right here. One answer, -1. The other 2 are plus or minus square root of 3. Okay, guys, one more final thing in this last minute here. Let me just move this out of the way. I'm also going to ask you to factor one difference of 2 cubes or sum of 2 cubes. So be ready for something like this, x cubed minus 8 maybe, or maybe something like x cubed plus 27, where you factor to the binomial times the trinomial using the sum or difference of 2 cubes. So this top one, it would be the binomial x minus 2 times x squared plus 2x plus 4. That's that easy to do. Use the formula so you could see how I did this. Binomial times a trinomial. What's the binomial right here? X plus 3, which means right here you have an x squared. Over here you have a 3 squared, which is a 9, and you have 3x in the middle. And if there was a plus and the binomial, there's a minus in the trinomial.